Okay, so we already learned about geometric sequences and series. Now we're going to add this word right there in front of it. So if you look right at the top of that sigma, there's an infinity symbol. So it's like, what does this mean? Okay, without worrying too much about formulas, okay, just going back to what we did on the very first day of this whole chapter, what this means is we should be able to plug a 0 in, and then we should be able to plug a 1 in, and then we should be able to plug a 2 in, and that would go on like this forever. It wouldn't be ... and then stop at this point. It would be just ... continue forever. And so you might think that the answer is infinity because you're adding up infinitely many numbers. Now, using the formula, okay, I want to remind you guys of the formula for geometric series. Okay, it was, does anybody actually remember?
AS plus the fraction of 1 plus r to the power.
Yeah, we had this weird formula like this. And you do not have to remember these formulas. It was the first term times, and then on the top of the fraction you had 1 minus r to the power of n, where n stood for the number of terms, and then over 1 minus r. So if we were to apply that formula here, okay, the first thing we'd have to do is figure out, okay, well, what would be the first term? Okay, so now I'm doing this using the formula and seeing if we get something, because I don't really want to type in infinitely many numbers in my calculator. I don't know if you do. I plan on going home at some point today. So what is this first term? What happens when you get a number to 0? And you can use your calculator, but y'all should really know this. 0.3, right. The fraction itself turns into 1. And then our r is always that number in parentheses. So remember, when we have r as a fraction, we like to put it in parentheses to make sure that we do everything correctly. And now, typically, we would figure out, well, how many terms do I have? But if I keep on going forever, I'm going to do something that's kind of weird, and I'm going to put an infinity symbol there, and we're going to see how this turns out. What do you think a number to the infinity power is? If it's a big number and you keep raising the power, it will get bigger and bigger. But what happens when you take a small number and raise it to a power? Yeah, I'm going to use 0.1 just because it's a little bit easier to use than 1/10. If I raise that to just the 20th power, look what happens to the number. It gets so small they have to use scientific notation. This is like 0.00 or negative, or sorry, point, and then 0.00000001. This is basically 0. And if I upped that number, it would be even more so. Okay, so here's what we get. And if you're kind of like, I can't handle this on a Friday, hang with me here. It's about to get way easy, but I want to explain to you why the formula works. When you take a small fraction, a number less than 1, and you take it to the power of infinity, it basically becomes 0. So what does the whole top of the fraction become? A 1. Because you're taking a small number to a really large power. It's like what I was showing in the calculator. And then on the bottom, we have this. Now, the way we're going to write this formula is they're actually going to go ahead and move this first term to the top. So I wanted to lead you to this new formula. Okay, so let's go ahead and type that in. 0.3 divided by parenthesis 1 minus, and you can either use 0.1 or you could go ahead and use 1/10. And if you could possibly round here, but that's not as accurate as writing this as a fraction. If you know what fraction it is, great. If you don't, hit the math fraction, and you get a third. So what ends up happening here, in this particular problem, the first term ends up being 0.3. The second term ends up being 0.03. The third term ends up being 0.003. And the next term, and so on. Okay, I'm spending a lot of time on this because I want you to understand how this works. If you understand how it works, you remember. Okay, so I told you guys to hang with me, those of you that are like, I can't do this on a Friday. Here is the formula if you're dealing with infinitely many terms. It's just the first term over 1 minus r. That's it. Look how nice and clean that formula is. It's easier than the previous formula. Okay, so I put a whole bunch of stuff here. It's kind of for A and B. All right. If you're watching the video, sorry, you probably have a bunch written up here. So that's where we get this formula from. It's not totally random. It's just a tweak on the old formula. All right? And you have to use this formula in order to solve these types of problems. So I already kind of said this, but this doesn't work on everything. Okay? It only works if the absolute value of r is less than 1. The reason there's absolute value bars here is because r can be positive or negative. That part doesn't matter. Okay, if r is positive, great. If r is negative, great. But it has to be basically a fraction. Okay? And not a fraction like 3/2. That wouldn't work because that's not smaller than 1. It has to be a type of sequence where the pattern gives you smaller and smaller and smaller numbers. All right. So if we have something like this, let's just go ahead and write it down again. If this is our formula. Okay, it's just the first term over 1 minus r. And the first term is not necessarily a sub 1. It's just wherever you start that series, like how we did before. Okay, if the absolute value of r is actually greater than 1, okay, or equal to, then the series has no sum. What this would look like is a pattern that's getting bigger and bigger and bigger and bigger, and so when you add all the numbers up, it never turns out to be a finite number. It turns out just to be infinity or negative infinity. So when you're asked just to decide if these have an infinite or finite sum, okay, and we don't have to evaluate them, the only thing you need to look at is the r. Okay, so just ignore everything else in the problem except for right here in the parentheses. That r is 0.8. Is that number, when you take absolute value of it, is that less than 1? Yes. So we would say this has a finite sum. And if we wanted to, we could apply our new formula to it. All right, what do you think about B?
It has no sum.
Why? What's R? 5, which is obviously more than 1. This pattern is going to just, every time the term gets multiplied by 5, the pattern is going to yield a bigger and bigger number. And so the sum is going to get bigger and bigger. So we can say this, we can call this sum no sum. We can call it infinite. And there's a couple of other words that we can put to this. Converging and diverging. Have you ever used those words before? Have you ever heard about converge and diverge? The books, yeah. So think about what diverge means. It means that there's not a straight path, right? It's not, you know, gonna work. This would be diverge. You don't have to know these terms, but for those of you that go on to take other math classes, this would be good just to be exposed to it. And this is going to be converge. It converges to a single number, okay? Yes?
What happens if there's not, like, if we go back to where we have to solve for the first term, what happens if there's nothing before the parentheses? Like, is it just...
It's like a 1. Our question is, like, what if this 0.3 had not been there? If you could just consider that to be a 1 there.
So you put the 1, which is 1 on top of whatever the r is.
Truly, you're a little bit of ahead of me, so I'm going to explain that in the context of this problem here, okay? Because it doesn't matter whether the number is there or not. What you're going to do here is to find your first term. Well, first of all, you got to figure out, can I even find the sum? Okay, don't use the formula when you're not supposed to. What is r in example A? 4. So there's no sum. You could say no sum, infinite sum. You could say diverge. They all mean the same thing. Okay, if you got to recognize that right away, because if you don't, you're going to use the formula, you're going to get an answer, but it won't be the right answer. Okay, look at B. In this case, r is 2/3. Can we use our new formula here? Yes. Okay, so that sum is going to be, now we have to find, this was the question. The broader question is, how do you find the first term? You always find it by taking this number and plugging it in right there. Okay, so 12 times 2/3, in this case to the 3 power. And you're probably going to want to use your calculator. This stuff is total. You can do this without using a calculator, actually. But I'm not even going to go there. And if you get a decimal, it's probably best just to go ahead and hit math fraction so that you can get something that's more accurate. So 32/9. My eyesight is working today. That's our first term over 1 minus r. Okay, remember it's our first term divided by 1 minus r. Now you do have to be careful with fractions. That's kind of why this is one of the early ones on, just so we can do this right now. Some of you have been asking me, how are you doing that copying and pasting? You can just go right up there, and if you just press enter, it'll bring it right down. You are going to have to do 1 minus 2/3 in parentheses. Now you may be thinking, should the 2/3 be in parentheses? Well, sometimes it matters, sometimes it doesn't. So if you're not sure, go ahead and put the 2/3 in parentheses. And if you get a decimal, go ahead and do a math fraction just to get a more accurate answer. So we get 32/3. That's our final answer. Okay. So now do y'all at least believe me that this is easier? So the formula is a lot simpler. You don't even have to find as much information. You do have to just make sure that you're only using this when you need to use it. So what do you guys think about C? Can we use the new formula on C? What is R? 3/2, which is a fraction, but it's greater than 1, so there's no sum. Or infinite sum, or diverge, however you want to say it. All right, what about D? In this case, R is -1/6, and that's okay that it's negative. The fact that it's a small fraction that's less than 1, we're good to go. We do need to find out the first term, though. And you always just find that by taking this number that's down here and plugging it in. 18. And this is not anything we hadn't already done. And so right here, you could go ahead and put the 3 and the -2, or you could go ahead and say, well, I know that's supposed to be 1. It doesn't really matter. If for some reason your calculator stopped working, you should still be able to do most of this without it. So we've confirmed that this is geometric. We've confirmed that R, absolute value of R, is less than 1. We found the first term. Do you feel comfortable in setting up the formula? Okay. First term, 1 minus, I know, it's Friday, it's been a long week. Y'all are not throwing things at me, so I should just be happy. Okay, please make sure, though, you are practicing this stuff with the calculator, because I don't want you to get to the test and realize you don't know where the parentheses go. Okay, because if you don't, that just tells me that you never did your practice. Okay, like right here, you may be thinking, well, how should I plug this in? I'm going to kind of be safe here. You could have changed that to a plus since it's minus negative. Whoops, I messed up there. And, you know, it's okay to have a decimal answer as long as it's correct to the 3 decimal places. A fraction answer is better because it's more accurate because you did not have to round. So negative 18/7. And that's okay if your answer is negative. That's going to happen some of the time, especially if R is negative. Okay, so there's 2 here for you to try. So I'm going to pause and I want you to try those. All right, so here are the answers. Can a couple of y'all check?
Yeah.
Make sure this all looks good. Do we have any questions about this? Simpler formula, great news. I will say some of you are going to love this formula so much you're going to want to apply it to every problem from here on out. You can only apply it to geometric series when the R is, absolute value of R is less than 1. Okay?